All right, we are going to do our study guide for the proportional relationships module that we're on right now. And let me get some volunteers to read over our vocabulary. So our first vocabulary word is going to go out to Drew. Please read about ratios. Awesome. And hey, we're going to recognize something that we're going to be using in operation very often in this module, right? On this test and in this review. Okay, it's right here. Everybody underline it, division. Okay, how do we find unit rates, everybody? How do we find unit rates, everybody? Okay, right? So usually we're going to be using division. There's occasional times we're going to use multiplication. And some people in the last block used a little bit of addition when they found a pattern to count up. Because, you know, there's ways to apply repeated addition in when we're talking about rates and ratios. Okay, who's got rate for us? Let's go, Leon. Okay, it's just a special type of ratio. And how does it differ from just a regular ratio? Well, there's these different units. So for instance, down here, we have a special ratio called a rate, all right? And it's because it's comparing miles to hours, right? So they're different units, all right? Miles is something that we can count or measure, and hours is something we can count or measure. All right, so they're two quantities, and they're being compared in this special way by division, like we said in the first part. Okay, so let's talk about now. We got a special type of ratio that's called a rate, and we got a special type of rate called a unit rate. So somebody read for us about unit rate. Go ahead, Jaden. Okay, right? We're looking for that 1. All right, so it has a denominator of 1. All right, and this one, is this a unit rate? 60 miles in 2 hours? No, because it doesn't have a 1. So what's the operation we're using today? Division. Thank you, all one of you. Okay, we have to divide to find that unit rate. 60 miles divided by 2 gives us that unit rate of 30 miles per hour. All right, so it's going to be fairly straightforward, but the confusing part comes when we have to kind of write it in the way of algebra, right? We have to kind of, mathematicians have come up with these, they think, super simplified versions, right? With just a variable represents all these words, and another variable represents all these words, and they made it so simple, but it can be confusing when it's really very logical. You guys can make sense of it very easily, but we get confused once we throw those variables in there. So let's see if we can connect it and make it as easy as possible, okay? Let's go to this next one. Remember, try to stay ahead. So if you're waiting there and you're kind of like, oh, what do I do next? Just read the next problem. Think it through. Try it. Try to get ahead, okay? Try to anticipate. Try to predict. All right, so that's what I want you to do now. Read about Russell and his running. So if Russell runs 9/10 of a mile in 5 minutes, all right, at this rate, how many miles can he run in 1 minute? So as soon as you see 1 minute or per something, all right, you're going to be finding your unit rate. And what operation do we usually use to find unit rate? Oh, we're getting better at this. All right, good work. All right, we usually use division, but how do we divide? Do we divide 5 by 9/10 or 9/10 by 5? Well, there's some clues in the problem, right? It says miles in 1 minute. So that's miles per minute. If we write that simple rate down, miles per minute, okay, this tells us how to divide. All right, it tells us what order to type everything in. All right, so we can just write, okay, so his rate was 9/10 of a mile, so we write that under the mile. Per, guys, what operation? Division, right? So per, we're going to divide. And then minute, well, we have 5 minutes. Now we have to go back to our first lesson of the unit and remember, how do we divide when we have these fractions? All right, Jason. It's keep, change, flip. Now we can't flip the 5, so we need to put a 1 under. We need to make it improper first. All right, and then we can keep, change, flip. So that's going to give us 9/10. Change the division to multiplication. Change the 5/1 to 1/5. And we know multiplying fractions, we can't cross simplify anything, so we just are going to multiply the tops and bottoms. And we're going to get 9/50. Weird answer, I have to admit. It seems a little weird. I like when I get whole number answers, not fraction answers, but it's still the right answer. And if we think about it, it makes more sense once we put the rate with it, okay? So it's 9/50 of a mile per minute. Is that a long distance? Okay, if you think how long a mile is, and you break it up into 50 equal pieces, and you only have 9 of those, right? 9/50 is a kind of not much of a mile, right? And how long did it take him to run 9/50 of a mile?
5 minutes.
He ran 9/10 in 5 minutes, but how long does it take him to do 9/50 of a mile? 1 minute, right? Because we just found the unit rate, so that's 1 minute. So that makes sense. In 1 minute, that's not a long time, right? He's running. He's not going to go like a ton of miles, right? 9/50 sounds right. A little piece of a mile in 1 minute. Okay, so how do we find that unit rate? We're just going to divide, and if we have fractions involved, we'll divide and use our keep change flip to change it to multiplication, simplify. Okay, now we have a little bit more of a challenging problem. I like these advanced problems. I hope you say, ooh, yes, an advanced problem. Challenge my mind so I can grow. All right, so I said, advanced, and you said, no, Mr. Woodruff, we love advanced problems because it helps us grow our brains. Woo! All right, see? Yes, they agree. All right, this is advanced because it says 15 minutes here, but the rate they want is in hours. So it means we have to convert how many minutes how many hours is 15 minutes, or what, more specifically, what part of an hour is it? It's not going to be a whole hour. So what part of an hour is that? I suggested looking at a clock, but people already had their ideas. Anybody have a good way to figure it out or know the answer? Chase? Okay, so 15, you would kind of look here, right? 15 minutes. 15 minutes would be out of the 3, right, if we have our clock here. And then if we break this into equal pieces, we have 4 equal pieces. So what fraction of an hour is that? 1/4. Yeah, 1/4 of an hour. Okay, so we have 1/4 of an hour. So instead of doing 15 minutes in here, we're going to do 1/4 hour. Because why do we know that? We have to get hours because they asked us to find the rate in miles per hour. Now, another way you can do it is say a whole hour is 60 minutes, and you put 15 over top, right? So we have 15 out of 60 minutes, and that would simplify also down to 1/4. So 2 ways to do it, right? Think of it on a clock and look at the sections, all right, or simplify it like that. Okay, now we can just write the unit that the units that we need. So we want miles per hour. We know that Josiah could do 5/6. We know that per is going to indicate what operation? Oh, one person. What operation? There we go. And then we have hours. So in this case, it's going to be 1/4 of an hour is 15 minutes. All right. So then we're going to keep change flip. I can cross simplify this time. What 2 numbers can cross simplify? Jason? 4 and 6, because they both can be divided by 2. So 6 divided by 2 is 3. 4 divided by 2 is 2. Then I multiply what's left on the top and what's left on the bottom. And I get 10/3. And now I'm sure Josiah is not walking around saying, hey guys, I can run 10/3 miles per hour. Doesn't sound very helpful. I don't get it. So instead, we could write that as Chloe? All right, so we change it into mixed number, 3 1/3. And that's going to be in miles per hour. Miles per hour. Okay? So that one was an advanced one. We put a little star there. We know it's advanced. That's one that you can look back and say, wait, do I understand how we did this? All right. All right. Go on to the next one. Try to get. So you should be looking at the next one. Always anticipating, always trying to stay ahead of the game. And that helps your brain be ready to learn. Okay, now, so that was just finding unit rates. But now we're going to apply it. When we always have the same unit rate, okay, between two quantities, or we call it equivalent ratios, okay, then we get this thing called a proportional relationship. Can anybody please read that definition for proportional relationships? Go ahead, Maisha. Proportional relationships, the definition there.
That now simplifies to the same ratio.
Okay, so we have those equivalent ratios. We have two different quantities that compare. So we're looking for these unit rates. Okay, we have a special fancy name for them. We'll get to that in a second. But if it always gets you an equivalent ratio every time between the pairs of values, write down equivalent ratios, guys. All right. You have those equivalent ratios, you have a proportional relationship. So go ahead and read the basic one. Excuse me. Read that basic one there. Right there. Yeah. And go ahead and test it out. Okay, read it. It says, is the relationship between the number of miles and the total cost proportional? How are we going to find that out? I wonder if it has anything to do with that operation you've been talking about. Yeah, lean forward, right? So it's going to be important that you try every time. Don't just wait. Don't just wait for me. So we have the basic one here. It just gives us two different ratios here. We got the one here that says 5-mile taxi ride costs Ayana $25, and then in this other city we have it's $18 for 4 miles. Now let me ask you guys, which unit rate would be better to find? Do you think we want to figure out how much dollars per mile, or do you think it's miles per dollar? Okay, just think it through. Just take a sec before you jump to one or the other. Just which one makes more sense? Like if you were getting a taxi, would you want to figure out how much money it costs per mile or miles for $1? Like which one makes sense? Which one would be more usable? Let's just take a vote. Who says the first one? Dollars per mile. Yeah, because then I know if my trip's gonna be 5 miles, I just times it by the price per mile and I get it, right? So this one makes more sense. Most of us said that one. All right. Okay, so then if we can figure that out, then we know how to divide. Even though the number are in the order of 5, then 25, we use our reasoning. We use what makes sense. We use our common sense here. And we say, oh, we're looking for dollars per mile, so we're going to do dollars per mile. So that means we're going to divide those two. So 25 divided by 5 gives us $5 per mile. All right. And then if we do the other one, $18 divided by 4 miles, that gives us $4.50 per mile. So is the relationship between the cost and the miles the same? Is it proportional? Is this relationship proportional? What do you say, guys? Proportional? Mm-mm. No, a lot of shaking, a lot of head shaking. Can't see that on the video, but they're saying no. we got two different ratios. So we're going to say non-proportional, non-proportional. The ratios are not equivalent. All right. Of course, as you finish that up, you'll go right to that next one and get going and see if you understand without me. Don't wait. All right, we're scooting over to our lesson 1.3, which had to do with tables. And again, pretty simple. If it's proportional, it's going to have equivalent ratios. Just like in lesson 1, they're just organized. All the numbers are organized in tables, right? So we're going to build tables. We're going to determine if they're proportional or not, the relationship is proportional or not, and we're going to see some patterns here. Okay, who's going to read this long one here for us? Proportional. What does it say there? Javian, nice and loud.
They also are the number of proportional to the
Yeah, driven, sorry, is proportional, right? So those two quantities, miles, is proportional to the total hours, right? So our two quantities are proportional to each other. All right, and then we have this fancy phrase, constant of proportionality, but it's not difficult because we know it just means unit rate. So it's that constant ratio. If you divide them all, get the same number, that's called our constant of proportionality or our unit rate between two variables. Okay? And then this right here, what operation does that show us? What operation is this? Y over X means what operation? Aisha? Oh, okay, it's the Y coordinate over the X coordinate, or what we get from that Y. But what operation I'm saying, so that's multiplication, division, subtraction, addition. See? It's division, right? Oh, surprise, surprise, more division, right? But this is where we get confused sometimes. It says Y over X, and we're like, what? All it's saying is the one variable divided by the other variable gives us the constant of proportionality, which all we've been doing the whole time is finding unit rates by dividing. So this is just a really simplified version of it, Y over X. All right, so just one of the numbers divided by the other number, that gives us our constant of proportionality. So let's jump right in here. Go ahead and fill out that table ASAP, soon as you possibly can, all right? Describe the relationship written. It says, does the relationship shown represent a proportional relationship? Explain. So it says the cost of a school lunch is $2.50. So if you buy one lunch, obviously that's going to be $2.50. If you're being kind and you buy one for your neighbor and you buy one for yourself, does anybody know how much that would cost you? $5, bingo. You must have been ahead of the game there. And if we have real nice, we could buy us one and our neighbor one. Jason says $7.50. And then finally, okay, Emma, what do you got for the next one? 10. There you go, $10. Good. Okay. Is this a proportional relationship? I think it's proportional because I just read it and it's just gives me a rate. It's like $2.50 per lunch. There's no extra fee or anything, right? So, and then if I check by that special operation, division, 250 over 1, 5 over 2, 750 over 3. Keep writing, guys. Come on, stay with me. Are those all equal? Yes, they all simplify down to that same unit rate of 250 per lunch. So it says, is the relationship proportional? We're going to say proportional. And when we explain, we're going to say that all of these pairs are equivalent ratios, right? And then once you get that written, go ahead down to the next one. All right, it's a little trickier. Try it out. So this next one, there's something different about it. Anybody want to describe what you see as different here? Connor? Oh, that's right. This one has that rental fee of $35. So if you remember that from our notes before, all right, then you're like, wait a minute, this is going to be a little different. All right. So again, we're determining if it's a proportional relationship or not. And when it describes it as a popcorn machine for $20 per hour, right? So we still have a constant increasing of $20. But the thing that's different is it has that one-time fee. Does anybody have the cost for 1 hour? Right? You have to pay the rental fee. Chase? Okay, yes. Well, you go up to the thing and they're like, to get this, you have to pay me $35. If you want to use it for an hour, you also have to pay $20 additional dollars. So 55, right? So, right, so we have $55 here because you have to pay that upfront fee plus the $20 for that 1 hour. Okay? Anybody have the next one? Brent? 75. So, right, you still have to pay that 35 plus the $20 for the first hour plus the $20 for the second hour. All right? But 35 only happens once. All right, and then we have what, Connor? 95, right? Now, Jaden, it says an upfront fee, right, or a rental fee. So that happens once. And then the 20 happens how many times? 3 times, right, for the 3 hours, okay? And then we have the last one. We have that last one already. Aisha? 115, because we had to pay the $35 and then we had to pay 4 sets of $20. Right? Now, we already probably know this is different than the first one we did, so this isn't going to be proportional. And why not? Because of this one-time fee, right? That one-time fee kind of shifts the numbers over so that when we divide, we're not going to get the same unit rate. If we were to do 55 divided by 1, 75 divided by 2, 95 divided by 3, and 115 divided by 4, these are not equal. So we'll put a little equal sign between them and slash through it. And it says explain, so we'll put non-proportional. And why? Because the ratios are not equivalent. And there is a one-time fee. Okay, that one-time rental fee is kind of what skews it or shifts it or messes it up, so it's not proportional. All right, so we're going down. Oh no, they had to come up with some fancy phrase that confuses us. What? All right, well, have no fear. You guys know how to find a unit rate because we've been using this this operation all day. Does anybody remember what that is? Yes?
Division.
It's division, right? So this is just a unit rate, and we find it by division. If it's a proportional relationship, it has to have a constant of proportionality. Now, the only thing that might mess you up here, and there's one problem coming up that messed everybody up in the last class, is kind of what order do you divide it? Okay? There's some clues. Sometimes they'll just name the rate out, and they'll say like miles per hour. So you know you're going to do miles divided by hours. In this case, you can kind of use reasoning. What just makes sense? If you're trying to, watch your diet or whatever, and would you rather know how much fiber is in one banana or how many bananas there are in 1 gram of fiber? Which one makes more sense? Okay, right. How much fiber in 1 banana? So right away, we know we're finding the constant of proportionality, which we just think, okay, that's a unit rate. I'm just dividing. Don't get confused by these mathematicians' crazy words. Okay, unit rate. Pen's not working. There we go. That's terrible. Try that again. There we go. All right, so we're not getting confused. We just know we have to divide, but sometimes we get confused on which direction to divide, which number to type in first. Okay, so in this case, since we want the grams of fiber per banana. That makes more sense to me, hopefully to you as well. Now we know we're going to do 9.3 divided by 3. We're going to do 18.6 divided by 6. All right, we're going to do 27.9 divided by 9. We're going to do 37.2 divided by 12. All right? Again, we're dividing. Crazy. And we should, because it says it's proportional up there. It doesn't really, but it says to find the constant of proportionality, so you assume it's going to be the same number. So the office ends the pass for them, and then they send a pass back. So what is that number? Everybody should be, instead of waiting for me to put that number up there, what should you be doing? Right? You think it. You're typing it in yourself. You're trying to get ahead of the game. All right? Those of you who are going to be passive and just, whatever Mr. Woodruff writes, that's what I'm going to put. Those people always struggle the most on the test. Okay? Because they never actually thought themselves, but they fooled themselves. But they're like, I'm doing the work. I will probably do well on the test. Nah, you actually fooled yourself. Okay, you only do well on the test if you're thinking the whole time and trying to stay ahead. All right, that's consistently going to be my message, right? Between that and like teach a man to fish. Those are my two messages. All right, what is that number, Connor? Okay, so that's 3.1 when we divide there. It's 3.1 when we divide there. It's 3.1 when we divide there. And again, 3.1. Seems pretty constant, if you ask me. Maybe that's our constant of proportionality. Since they're all the same, we call it, just for shorthand, mathematicians always trying to write less. Constant of proportionality equals 3.1 grams per banana. All right, so we have our answer. And how, what operation did we use again? Operation. What operation? Division, right? I know that word operation, nobody knows what it means right off the bat, but it just, you have four operations that we usually focus on, right? And this one today is division, and more division. All right, okay, closing in on it. Hey, so now we're dealing with graphs of proportional relationships, right? We just did tables. We found constant of proportionality in tables. Now we're just applying it to graphs. So we're going to take these tables, we're going to put them in graphs, and we're going to see what we find. We already know graphing a proportional relationship, it'll always be two things. It'll always be a straight line, and, it's going to be a straight line, and it's going to go through the origin. Two things. If you get both of those, bop, bop, you got a proportional relationship. And that means any dot on that graph can be divided. Wow, no way. Division again? Yes, any dot on that graph, take the two numbers from that dot, divide it, and that gets you your unit rate or constant of proportionality. Now you guys are so intelligent, you probably know already which of these three is proportional. You can just kind of look at the table and know. Okay, the math is pretty simple. This first one, circle this. That gets us started pretty well. That looks like the origin to me. 0, 0, put a dot. Okay, then we got 1, 6. We got 1, 6. That's going to take us. Oh, I'm going to put the other numbers in because that helps me. I'm going to go up here, put all these other numbers in. All right. I got 1, 6. Yay. I got 2, 12. Oh, looks like it's shaping up to be a straight line through the origin. 3, 18. Bingo. Get that straight line going. Beautiful. So we know that that one is proportional. All right, now, how could you have already known that just looking at a table? All right, well, if we did 6 divided by 1 and 12 divided by 2 and 18 divided by 3, hey, yeah, it's obviously getting the same number, that unit rate of 6 feet per minute. Okay? Now, there's a special point here. Let's just indicate this point here, put a little arrow to it. Okay, that is 1 comma 6. Why is that significant? Why is that point important? Why is that point useful? What do you think, Drew? That's unit rate right there. Okay, now we would write it in a different way. We would say, oh, 6, that means 6 feet per minute, right? 6 feet per minute is what that point represents. Because this is a straight line through the origin, this special point with the 1 in it is going to be our constant of proportionality, aka unit rate, also known as unit rate. Some of you are already graphing the other one, I can see. Okay, some of you are already ahead of the game. All right, get there. Let's go. Oh, looks like origin again. Hey, maybe this is going to be proportional again. What do you guys think? Proportional? Okay, so then we're going to graph that next one. We got 1, 8. Again, we see the 1 there. Maybe that's going to be the constant of proportionality or the unit rate, maybe. Okay, we go up 1, 8. Wait a minute. Wait a minute. We got 2 is also at 8. Doesn't look like a straight line through the origin anymore. Okay, and we got 3, 15. This is a little tricky because I know that this is going to be 14. So that means right in between 14 and 16 is going to be 15. So I'm going to follow up this 3 line. I get to 14. I go to 16, it's too far, so it has to be right on that gray line, but right in the middle. Okay, and then I zoom, 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 a little zigzag. So it checks off one of the key features. It goes through the origin, but it's not a straight line, so we're going to put non-proportional. All right, and that final one, hey, right off the bat, we got 0, 10. We have the 0 here, but we don't have the 0 here. So it's going to be at 0 weeks, we're already up here at 10. So does this go through the origin? No. Is it a straight line? Okay, so 1, 12 would be, I'm going to put these in, 10, 12, 14. Okay, so over to 1 week, up to 12. Over to 2 weeks, up to 14. Over to 3 weeks, up to 16. Every week it goes up 2, but it started at that kind of already at $10 balance, right? There's like that one-time upfront amount. Okay, so this hits one of them, it's straight, but doesn't hit both. It doesn't hit the origin, right? So this is also non-proportional. If you got that, if you feel good about that, then you are going to go to that next one down below. Okay, it says find the constant of proportionality for this graph. Yeah, so then write it as a rate. Remember how you did it on the graph? So what does that mean? What is that? You want a graph or a growth here, so. Yeah. See how much the price is per slice. 2 slices, how much? Oh, I forgot the pause in between. All right. Here we go. We're trying to find the constant of proportionality. At first, we're like, big words. No, I'm going to fail. And then we're like, wait. Oh, I know that. That's just something easy. It's a simple concept. and it's finding the unit price or the unit cost or the unit rate. All right, unit rate. And then we have to explain what that unit rate means. So we're probably going to divide or find a special point that tells us that unit rate. It helps, I guess. We kind of like write it like that, or we could write it out like this with the slices and the cost. But anybody know? Show me on your fingers how much it costs for one slice. And if you don't know, if you're just kind of looking around like, where they get that? I think this is kind of right at 1. So that would be one slice, $2. Okay, this dot is 2 slices, $4. Right here, if I go up to that dot, that's 3 slices, $6. And that final dot is 4 slices, $8. Shake your head or nod. Nod if you can see how we got that $2 per slice. Okay, $2 per slice. So, right, we can put it in our table if we want. 1 for 2, 2 slices, $4, 3 slices, $6, 4 slices, $8. However you want to look at it. All right. How do we get unit rate usually? We just divide. So 2 divided by 1. 4 divided by 2. 6 divided by 3, and 8 divided by 4. They all come to a beautiful $2 per slice. Okay. So the COP is equals 2. And it says explain what it means, which means it costs $2 per. Right? Lots of different ways to see and apply the same exact thing over and over and over and over again. Okay. So, okay, start with 10. Action. So we're finishing up with, we have to, this is probably the part that people get confused about the most. When we're dealing with equations and it starts looking like this, that's when people just are like, I give up. This is too hard. Okay. But there's a useful form. This is a useful form. And we introduced it yesterday with the graphs. Okay. And we put on those 9 graphs. Remember the 9 graphs that were the quiz rate, and then I gave it back and you wrote equations for all of them, right? All you had to do was once you found that unit rate, that's the amount you were multiplying by. Mathematicians like to say, okay, all math people are going to do it the same way. So that, if I do some math over here in the US, and then I want to share it with somebody over in Europe, okay, we can look at each other's things and each other's math and be like, oh, I get that because we do it the same way, right? They kind of set a format so that it's consistent throughout everybody over the world, okay? But in this, it sometimes confuses 7th graders. All right, like what does this mean? Y equals kx. How many of you are a little bit like, I don't think I learned this. I don't know what's going on. Okay, yeah, all of us probably. All right. Jacob would raise his hand, but I don't know, it's too heavy today. Something like that. All right. Anyway, but this is all it is it's one of the quantities. Like for instance, total miles traveled in X hours. Okay, K would be the miles per hour, the unit rate. Okay, so that right there, that number that we're multiplying by is always the unit rate. Just put a little arrow in there. Okay? And I'll show you how we did it yesterday and how it relates to that equation. It's simple. All you do is find the unit rate, plug it in there, you got your equation. Okay? So let's look at, JC. JC, it's almost Jace. All right, JC bought 8 gallons of gas for $31.12. Write an equation relating the total cost Y. Everybody, total cost, instead of saying that long phrase total cost, now we can just say Y, and everyone knows we're talking about the total cost, okay? See, It's not complicated. So this means we can get the total cost if we do something times X. Well, what's X? The number of gallons of gas is going to be X, okay? So gallons of gas is going to be X. So if we multiply the gallons of gas, the number of gallons, times some number, we'll get our total cost. That's all we're trying to do, okay? So this is a proportional relationship. How can we tell that unit rate? How can we find that multiplier number? Remember, you talked to us about, we're really early on in the module, Jay. You talked about, oh, I just multiply by the same number every time I get the answer. Right? How do we get that multiplier? I wonder if it's that important operation we've been talking about. You think we divide? Okay. They give us this rate here. So how can we find the unit rate right there? All right. We want to know how much the cost per gallon is. That makes sense. All right. So we're going to go ahead, 3112 divided by the 8 gallons. And somebody tell me what that unit rate is. Yeah, calculated, right? Rock and roll. Yeah. Okay, $3.89 per gallon, right? Hey, everybody on your calculator. How much for 2 gallons? What would you do on your calculator to get how much it would be for 2 gallons? Yeah? You could do that plus that. What other operation could I do? Times 2, right? So the cost per gallon times the number of gallons, right? What is it? Oh, okay. All right. So if we know the unit rate, so step 1, find COP, and then we take that COP and we plug it into our formula, y equals blank x. Okay, y equals blank x. What goes in here again? Our unit rate. Okay. All right. What does that mean? What does that mean? Well, y represents the total cost. So to find the total cost, just multiply 3.89 by, what are we going to multiply it by? What does the x equal? What does the x represent? No, x. 3.89 is the unit rate. Up here, guys, what does x represent? The gallons of gas, right? By the gallon. Okay? And that's what, to do that, Connor said. We're just doing, to find how much it would cost for 2 gallons, you just multiply by 389. What if I wanted to find 10 gallons of gas? How much that cost? What would I do? 10 gallons of gas would cost, you just would? Exactly. That's what this is saying. It's like a really simplified, like mathy way to say, if I want to know the cost, I just multiply the money times the gallons. That's it. So you'd say 3.89 times 10 would equal what the total cost is, okay? So this is confusing at first, but once you get used to it and really see the y as meaning total cost and see the x as meaning gallons, it makes more sense. All right, you're going to pack that up, guys, and good job. Let me